This is Unit 3, Linear Relationships, Lesson 4, Comparing Proportional Relationships, and this is Activity 2. There are actually only 2 activities in Lesson 4, but there are 3 problems that go along with this second activity, which is called Summer Jobs. So I'm going to break this up into those, these videos up into those 3 problems. I'm going to do each problem separately, or record each problem separately. So the first problem is Elena and Jada. And remember the 4 representations: an equation, a description, a table, and a graph. And in these 3 problems, they give you 2 of those representations and ask you to answer some questions about each situation. So in this first problem, they give you just the equation for Elena. And so Elena's equation is y equals 8 40 times x. Now they also have to tell you what x is and what y is. And so it borders on a description, but it really is just the equation, just telling you this information, but also giving you an idea of x and y. And Jada, they give you just only the description. You're going to see how simple that is in just a moment. So that is right here. So on the left side is Elena's equation. So Elena babysits. Her earnings are given by the equation y equals 8 40 times x. Well, that 8 40 is $8.40, where x represents how many hours she works. So she works this many hours, x hours, at $8.40 each hour. Then how much money does she make? That is given by y. That's the value that you calculate given the number of hours that she works. So we're going to go into that in some detail. Jada earns $7 per hour mowing her neighbor's lawn. So look how simple that is. And from that information, you're supposed to figure out what x is, what y is, what the constant of proportionality is, the equation, and answer this question of who makes more money after working 12 hours, how much more do they make, and explain how you know, and then what's the rate of change, and then how long would each person have to work to earn $150. So those are the 3 questions. All right, so if we go over here to Jada and look at that $7 per hour, and if you just write that out, $7 per hour, so dollars per hour. Remember, this line here means per. That tells you that that is y over x, because the constant of proportionality is the value of y, so it's this the length along the vertical axis, the number of units along the vertical axis, divided by the number of units along the horizontal axis. So this is also the slope. It's also the unit rate, but in this case, it's the constant of proportionality to figure out which is y and which is x. So that makes the number of dollars, which is m, which is money, in this equation that we're going to write, that is the y value. So those are the units along the y-axis. H is hours. That's the h value. So those are the units along the x-axis. And that makes sense. We'll look at the graph in a moment. But if you make a certain number of hours, so if you go out along the x-axis, oh, I make 10 hours, I work for 10 hours, how much money do I make? And then you have to figure that out, where it matches up, where it meets up on the y-axis. So you go back to this equation that we know from long ago, y equals kx, and you know that k is the constant of proportionality. So now you know the constant of proportionality is money per hours. So that's $7 per 1 hour. $7 per 1 hour. So now you can write the equation. The amount of money that Jada earns is equal to 7 times the number of hours she works. And that 7 is $7 per 1 hour. So we're kind of answering the rate of change at the same time. So now let's go ahead and use this equation to figure out how much each person makes. So Elena's equation is given to you. Y equals $8.40 times the number of hours she works. And Jada, we just figured out her equation. That is money equals $7 per number of hours that she works. So she works for less money, $1.40 less. Every hour she makes $1.40 less. So in 12 hours, Elena makes 12 times $8.40. So I'm going to use the distributive property. 12 times 8 is 96. So you can read this as 8 plus 40 cents. 4 times 12 is 48. So 4 tenths times 12, or 40 hundredths times 12, is $4.80. Add them together, you get $100.80. So 96 plus that 4 gives you the 100. You have 80 cents more. Jada's amount of money in 12 hours is 7 times 12. Well, 7 times 10 is 70. 7 times 2 is 14. 70 plus 14 is equal to 84. So Jada makes $84 in that 12 hours. So how much more money does Elena make than Jada make? So then Jada makes in that 12 hours. Well, that's $100.80 minus $84, or just think of it as 84 plus 16 gets you to 100. You need to add 80 more cents. So that is $16.80 more. And if you go up here, they ask you what the rate of change is. The rate of change is the concept of proportionality per 1 unit, because that's what that is. $8.40 per 1 hour. $7 per 1 hour. So that's the hourly rate, or the rate of change. How much is this? How much does it change, and how much money she makes each hour for each person? Okay, another way to calculate the $16.80 is every hour Elena makes $1.40 more. So she makes $1.40 more than $7. So you can just multiply 12 times $1.40, 12 hours times, gee, she makes $1.40 more. How much is that? That's 12 plus, so 12 times 1 is 12. And that 40 cents times 12 is $4.80. We already did that one. So 12 plus $4.80 equals that $16.80. So 2 different ways to figure out how much more money Elena makes in 12 hours than Jada. Okay, a graph of these. And it doesn't ask you to draw the graph, but it's a good idea. So you're going to put hours on the x-axis. You know you're going to go out to 12 hours. So if I just grab this off of Doceri, this is one of the background patterns in Doceri. So I just grabbed this off of Doceri and I counted out. I need to get out to 12 hours. So I just made each one of these darker lines here an hour. Counted out to, actually I went out to 14 hours. And then I know I have to get up to $100. So that's $100 way up here if I start at this line. So it's 10, I count by tens. And I place a few points. So after 1 hour, we know that the unit rate, 1 hour, is $7 for Jada. So that's right here. It's kind of hard to see. And it's $8.40 for Elena. So this is $8, and you go up about halfway to $9. Just place a point there. You're kind of guessing a little bit, but that's okay. After 2 hours, it's $14. Well, that's right on this line. This is 10, 12, 14. It's right there. And for Elena, 2 hours is $16.80. So this is $16. I actually went a little bit too far. It should be closer to 17. So you can see why this point is a little bit above once you draw the line. I placed it a tiny bit in the wrong spot. Move it down just a tiny bit. 5 hours, 5 times 7 is 35. Well, this is 30, 2, 4. So 35 is halfway in between right here. And 5 times $8.40. 5 times 8 is 40. That would get you to right here. And 5 times 40 cents is $2. So that's $2 more. So that's $42 right there. And 10 times 7 is $70 right here. And 10 times $8.40 is $84 right here. 80, 82, 84. And finally, if you go out to 12 hours, you see that this is $84. And this line for Elena is $100.80. And the difference, this difference right here, is that $16.80. So you have to you would have to add $16.80 more to Jada's to get up to Elena's. And so if you looked at this length and figured that out, if you counted the number of units, you'd end up with $16.80. And here's that calculation of 12 times $1.40 equals 12 times 1 is $12, plus 12 times 40 cents is $4.80. Add them together, you get $16.80. The last question is, how much does each person make? How long does it take each person to make $150? And so here's that $150 right here, and here's that $150 right here. And what I'm doing is multiplying that $150 by the reciprocal of the constant of proportionality. How do I know how to do that? If the equation is the amount of money equals $7 times the number of hours worked, for example, then the number of hours worked is equal to the amount of money times the reciprocal of the constant of proportionality. So if you go backwards, if you're given, in this case, you're given the amount of money is $150, so you're given Y, and you're asked to calculate the X value. So in that case, you multiply by the reciprocal of the constant of proportionality. So you can rewrite the equation as the number of hours is equal to the reciprocal of the constant of proportionality times the amount of money she makes. So she makes $150. How long does it take to make that $150? You multiply by the reciprocal. And so, of course, it makes sense that Elena is going to take less time to make that $150. So it takes her about 18 hours to make $150, whereas it takes Jada about 21 and a half hours. So 3.5 hours more she has to work to make that same amount of money, to make that $150. And I gave you a video in, this is from lesson 3, the practice problems in lesson 3, about multiplying by the reciprocal, basically about going from knowing the Y values to calculating the X values, going backwards. So you can use this QR code, scan it in, and go to this video, or this is the link to that video right there. So that's more on multiplying by the reciprocal.